Oh, there's
Wait.
too many chunks.
Factors, we have, you can just pick them out if you want.
Mm,
2 games to play with factors. The first game is finding all the factors. This is the game we did with our factor game that we played a moment ago on the board. You want to find all the factors of a number. And to do this, you make like a horseshoe shape. So to find all the factors of 66, does 1 work? Always. 1 times 66 is 66. Does 2 work?
yes,
Yes. What matches with 2?
33.
33. Does 3 work?
Yes.
Yes. And 3 goes with 22. Does 4 work? No, 4 is not going to work. Try it with your calculator if you want, but it doesn't work. Does 5 work? No, it doesn't end in 0 or 5. Does 6 work?
Yes.
Yes, 6 goes with 11. Does 7 work? No. 8? No, because 4 didn't. 9? No, 6 and 6 is 12 when you add up the digits, and 9 doesn't go into 12. Does 10 work? No, and now I'm back to 11. So if 11 and anything else worked, it would need a small number to match with it. We'd already have seen that. So those are all the factors of 66. The GRE might ask you, how many factors does 66 have? And then I would count them. 1, 2, 3, 4, 5, 6, 7, 8, right? Using my board. 1, 2, 3, 4, 5, 6, 7, 8 factors, if they said how many. Okay, which has more factors, 36 or 40? So let's first do 36. 1 and 36 works. Does 2 work?
Yes.
Yes, 2 times 18. Does 3 work?
Yes.
Yes, when I add them up, 6 and 3 is 9, and 3 goes into 9. So it's going to work. It's going to be 12. Does 4 work? Yes. 9 times 4. Does 5 work? No. Does 6 work?
Yes.
Yes, 6 times 6 is 36. And then we've gotten to the same thing, right? If 7 or something worked, then it would need to be a smaller number for it to go with. So how many factors are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 factors. How about 40? Well, 1 and 40 will work. Does 2 work?
Yes.
Does 3 work? No. Does 4 work? Yes. Does 5 work?
Yes.
6? No. 2 and 3 don't both work. 7? No. And then we're up to 8. So we're done. If anything 8 or bigger would work, we would need a small thing to go with it. It would be on the board already. So this time, 1, 2, 3, 4, 5, 6, 7, 8 factors. So which has more? 36 has 1 more factor. See how that game works? So this is your factor game kind of thing. A second game you can play is finding the prime factors. This is the factor tree stuff, which I'm assuming everyone has seen, but as usual, maybe not been taught enough about. So a factor tree is when you make usually 2 factors out of every number on the board until you're stuck and can't do it anymore. So this person started with 48 is 6 times 8. Can you break apart 6? Sure, 6 is 2 times 3. Can I break apart 8? Sure, 8 is 2 times 4. I can't break apart the 2 or the 3 or the other 2, but the 4 I can make 2 times 2. So then I wind up with a 2, a 3, a 2, another 2, and another 2. And it's polite when you're done to put them in order. So I have a 2 times a 2 times a 2 times a 2 times a 3, and I get to 48. And I should make X's instead of dots. And you can check on your calculator. 2 times 2 times 2 times 2 times 3 is 48. Let's make a different factor tree that doesn't start with 6 and 8. What are 2 other factors of 48?
2.
2. Okay, so we can go to 2 and 24. that the 2 is done, 24 becomes
Oh,
12 and another 2. The 12 becomes 6 and 2. The 6 becomes 3 times 2. There's 2 ways people draw this. They're both equally correct. How you get these wrong on a test is just by not including one of your leaves of the tree in your final answer. So you want to make sure you don't forget the leaves. Some people draw lines that keep bringing all the leaves down to the bottom, and that way you don't forget them. Other people like circling the leaves. That works too. So I'll be a circly person.
you have it in
So
order.
a
Like,
2 times a 2. It's polite to have them in order because that way, when I'm comparing with my neighbor to see if I got my same answer as my neighbor, I don't have to like
okay,
fuss with it, right? We'd have the same thing written down.
okay.
But it's not wrong if you didn't have them in sorted. Notice my left factor tree doesn't have a 24 on it. It doesn't have a 12 on it. My right factor tree doesn't have an 8 on it. So this isn't going to find all the factors. It's not that same game that we did with the horseshoe shape a moment ago. But this gets you the prime factorization at the bottom, which we'll use next time when we're dealing with fractions. So 2 very different games. Why don't all of you try 24? Do that yourselves a moment. And then I will do it on the board and you'll see if you get the same thing I do. Okay, where did people start breaking apart 24? There's lots of ways to do this.
I did 2 and 12.
2 and 12. Okay, if you did something else, that's okay. They're all equally good. The 2 is done. The 12, then
I mean, 4 and 3.
4 and 3. The 3 is done. So we wind up with 2, 2, 2. And the 3. And they've circled all of my leaves to make sure I didn't forget. Should we do 18 just to make sure we got it, or are you okay with that many examples? Let's do 18. What would we break apart 18 into? 9 and 2. Okay, if you did 6 and 3, that works also. The 2 is done. The 9 becomes 3 times 3, and that's done. So I have a 2 as my smallest number and 2 3s. This should look very unfulfilling. We haven't actually seen why you care about this yet, but we'll do that next class.